Good morning to all. I am Dr. Ashokkumar Manoharan, Senior Resident, Department of Anesthesiology, SLIMS. Today, I am going to talk about basics of ventilator. This is the ventilator most commonly used in our institute. This is a Macket servo eye ventilator. The following parts are to be explained. It consists of several parts. This is a Macket servo eye ventilator. It consists of several parts. It contains power pick cards for ventilator as well as compressor box, and it also contain oxygen supply tube as well as compressor tube for vacuum as well as and two plug cards, one for power supply and power supply for main ventilator as well as power supply for compressor. And this is the black and white color also. It is a tube for compressor for vacuum. And another white color tube is for oxygen. And this is a circuit which consists of both inspiration as well as expiration tube, and it contains YPs which is connected to the patient. It is similar to the closed circuit used in Boyle's machine. So it have separate tubes for both inspiration as well as expiration, and it having YPs connected to the patient and both end connected to the other end machine end connected to the ventilator. And these are the following parts connected to the hospital supply. This consists of two power supplies, one which is connected to the white color one which is connected to the power supply for ventilator, and black one is a power supply for connecting to the compressor box, and white color hose is consists of oxygen supply which is connected to the oxygen pipeline system, and another black and white tube it is from the compressor which causes vacuum or air which is connected to the hospital supply. And this is the connection showing power card, plug card connected to the power supply in the hospital. Both white color tube which is for ventilator and black color tube which is used for compressor box. And this is the main ventilator, magnet servo eye ventilator, which is used in our hospital. And this is the supply. This is the hospital supply line, which consists of white color tube, which is connected to the hospital supply, power hospital oxygen supply, and black and white tube, which is connected to the compressed air tube. Then black and white compressed air connected to the compressor, and white color tube is connected to the ventilator. That black oxygen white one is mainly used for oxygen supply, and black and white one used for the compressed air supply, and backup is for suction. And this is the compressor box, which is supply FiO2 fraction of inspired oxygen, which consists of oxygen as well as air supply, the air which is provided by the compressor tube, and the oxygen is supplied by the hospital oxygen supply. In case of emergency, it is connected to the oxygen cylinder in which oxygen pipeline supply which is not available or supply is not enough. This is the switch on off switch for the ventilator. We can switch on to the power on the ventilator. And pre-use check, we want to check the pre-use check, we want to go the option yes. Before proceeding to the before starting the ventilator, first we want to check pre-use check for any oxygen leak or any air leak, to any pipeline leak, to detect pre-use check, which is mandatory for our ventilator before connecting the patient to the ventilator. It is regular. And this is the expiratory cassette which is connected to the ventilator. So this is a expiratory cassette which is a filter causes expiration to be uh, evacuated. And this is the oxygen inlet tube which is connected to the humidifier. Then it is on the other end there is the expiratory connection which is connected to the cassette. It consists of mainly inspiration and expiration tube. First, it is connected to the humidifier. Then, first the minimum was the small pipeline which is connected from inspiratory end to the humidifier. From the humidifier, it's connected to the Y piece. Then, from Y piece, there will be a expiration tube. Then, expiration tube which is connected to the expiratory cassette. This is the circuit for the ventilation. This is the expiratory cassette which are connected to the expiratory tube, which is in turn connected to the Y piece. From other end, there will be inspiration tube which is connected to the humidifier. From the humidifier, it is connected to the inspiratory end of the mechanical ventilation. In this picture shows the expiratory cassette is attached to the ventilator, magnet servo type ventilator. Then once it is attached, the lock should be attached in the expiratory cassette should be attached and the button should be pressed for the complete attachment of expiratory cassette to the mechanical ventilation. And from the inspiratory end of the ventilator, it is connected to the humidifier. From this picture shows the inspiratory end of the ventilator is connected to the humidifier. From the humidifier, there will be inspiration tube RSS. From the inspiration tube, there will be a Y piece, and another end of the Y piece, there will be expiration tube. From the expiration tube, which is connected to the expiratory cassette, which is attached to the ventilator. These are the basic circuit for the mechanical ventilation or ventilator. This is the attachment showing inspiration end of the mechanical ventilation. From the inspiration end of the mechanical ventilation, mechanical ventilator is connected to the humidifier. From the humidifier, another tube arises, which is the inspiratory tube. From the inspiratory tube, it is connected to the Y piece. From the Y piece, other end of the Y piece, there will be expiration tube. From the expiration tube, which is connected to the expiratory cassette, then the expiratory cassette is attached to the ventilator. This is the complete circuit of the ventilator. This is the inspiratory end of the ventilator, the inspiratory end of the ventilator, which is connected to the humidifier. From the humidifier, another tube arises, there will be a inspiration tube. From the inspiration tube, which is connected to the Y piece. From the Y piece, it is other end of the Y piece, there will be expiration tube, and the expiration tube is connected to the expiratory circuit here. From the expiration circuit, which is connected to the expiratory cassette. From the expiratory cassette, it is attached to mechanical ventilation with the button attached. Click zone will be here. Then the expiratory cassette will be attached. Then this is a complete circuit. This is showing inspiratory end of the mechanical ventilator as well as expiratory end of the mechanical ventilator. Then the humidifier then the Y piece complete circuit, which is connected to the test line. Then we want to proceed to the pre-use checkup. Pre-use checkup is mandatory for all ventilators before we connect it to the patient, because pre-use check can detect leaks, any oxygen leaks, tube leak, circuit leak, as well as leak in the any other parts of the ventilator. So pre-use check is mandatory. Yes, we can proceed to Pre-use check by click yes on the screen of the mechanical ventilator. Before connecting any patient to the ventilator, first it is mandatory for pre-use check before connecting to the ventilator. Before patient ventilation, pre-use checkup is necessary. Having following tests. First test will be the internal test, then barometer test, then gas supply test. Fourth one will be the internal leakage test. Fifth one will be the pressure transducer test. And sixth one will be the safety valve test. And seventh one will be the oxygen sensor test. Then next one will be the flow transducer test. Next will be the battery switch test and patient circuit test. And another last one will be the alarm state test. This is the pre-use check when following parameters to be tested. First will be the internal test, and next will be the barometer test, and next will be the gas supply test, then next will be the internal leakage test, then pressure transducer test, then safety valve test, then oxygen cell as well as oxygen sensor test, then load transducer test, then battery switch test, then patient circuit test, then alarm state test. Then connect the test tube between the inspiratory outlet as well as expiratory inlet. From the machine source, the inspiratory end of the ventilator, which is connected to a small tube, which is connected to the humidifier. From the humidifier, then the inspiratory tube will be arranging, and the inspiratory tube is connected to the white piece. Then other end of the white piece is connected to the another end of the white is connected to the which is expiratory tube, which is connected to the expiratory gasket, and the expiratory gasket is attached to the ventilator. This is a complete circuit of the mechanical ventilator. Complete circuit of the mechanical. And for pre-use checkup, this is a normal circuit. For pre-use checkup, we want to connect a small test tube between inspiratory end as well as inspiratory outlet as well as inspiratory inlet. Normally, there will be a separate for inspiration as well as expiration tube. For pre-use checkup, there is a small tube which is normally connected to the inspiratory inlet to the humidifier. In for pre-use checkup, it is connected to the inspiratory outlet as well as expiratory inlet. And next, following barometer, gas supply, pressure transducer, safety valve text, following test will be proceeding the check oxygen sensor, flow transducer, and finally battery switch test will be run. One or more batteries to be replaced. Check batteries in status for more information. In case of emergency power shut off, we have a battery backup for the safety for the patient which is ventilated. So battery test is necessary for the all mechanical ventilation, particularly in hospital setup. There is a poor electrical supply. So batteries, one or more batteries to be replaced and the battery status to be checked for more information to prevent for safety of the mechanical ventilated patients. And for battery switch test, either switch off the power cord or unplug the power cord for to know the battery status for the safety for the mechanical ventilation patient before. Please check a battery switch test is necessary to check the battery status. For this test, please unplug the power cord to check the battery status. Once the battery switch test is completed, then reinsert the power cord. Once you know the battery status, there is enough power supply for the patient to be ventilated. It is a necessary safety step, particularly in situation where a power is shut off. Then patient circuit test. For the patient circuit test, there is a small tube which is connected from inspiratory outlet to the humidifier. From the humidifier, there will be a tube called inspiration tube, which is connected to the humidifier. From the inspiration tube, Y piece is connected. At the end of the Y piece, there will be a expiration tube. From the expiration tube, it is connected to expiratory cassette. From the expiratory cassette, it is attached to the mechanical lens. This is complete circuit. Stem of the Y piece, which is connected to the L-shaped tube, which is then the previous checkup, the last before step, block the Y piece for the patient circuit test. Click OK button. Then this is the pre-use check running. First, the internal test is passed. Then barometer test is passed. Then gas supply test is not completed. For this necessary test to be passed, particularly internal leakage test, pressure transducer test, safety valve test. Oxygen sensor is enough. It is a very safety feature. Otherwise, it is also okay. Then flow transducer test is passed. Battery test is passed. Then patient circuit test, which is running. By blocking Y piece, we can test the patient circuit test. Then final step will be the unblock Y piece. Then click OK button for patient circuit test. Then do you want to compensate for compressible volume or connect? Either compensate for compressible volume by connecting to the compressor or directly connected to the compressed gas supply. Compressed air supply by clicking S button. Then do you want to delete previous old patient data trends, and even if you want to proceed, yes or otherwise no. For all patients, we want to check the data for the ventilation to know the details of the mechanical ventilator system by clicking S button is necessary for all new patients which is connected to the mechanical ventilator. Then this is the final test after the all the pre checkup is done. Then the machine is all the previous test is done, and then the machine should be in standby mode. We can start the ventilator by clicking the start ventilation. And this is showing previous checkup is passed. Patient circuit details of previous check when the timing set up. Then patient circuit test when the timing set up. Another will be either adult patient or infant patient. It is then other option will be the invasive ventilation or non-invasive ventilation. Then above the patient, it is a modes of control, either volume or pressure control, or in aspect control, or intermittent mandatory ventilation, or any other non-invasive ventilation. And this is a patient status. Then it is a battery checkup. Additional settings will be the FiO2 or oxygen concentration. Then another will be the positive end expiratory pressure. Then another parameter which is a respiratory rate. Then another parameter, main parameter will be the tidal volume. Then additional checkup by clicking additional button. Either we can use by touch screen or by using the button on the downside. Then all the respective images shows the most commonly used ventilator in our institute. For to know the details, we want to know the complete setup of the ventilator used in our institute. That starts with the power supply with the white color one and the black color one, which is connected to the black cards, and the pipeline supply. White color one is connected to the hospital pipeline supply, and black and white one is connected to the compressed air release. Then switch on the ventilator. Then next step will be the connect the inspiratory. From the inspiratory inlet, small tube which is attached to the humidifier. From the humidifier, another tube will be inspiration tube. Inspiration tube which is connected to the Y piece. From the Y piece, other end of the Y piece, there will be an expiration tube. From the expiration tube, which is connected to the expiratory cassette. Finally, expiratory cassette is attached to the mechanical ventilator. This is the complete circuit of the mechanical ventilator. Then, following pre-use checkup should be done. First, start with internal test. internal leakage test and main test will be done. Finally, battery backup checkup and patient circuit test alarm setup all to be done. Then we want to enter the patient data. Finally, ventilator will be in the standby mode. We can start the ventilation by clicking the start ventilation button. And finally, we proceed to the main system of mechanical ventilation theory part. The fundamental operations for positive pressure ventilation. Define positive pressure ventilation. Anyone in the class, please tell me what is positive pressure ventilation. Okay, I will tell about that. Positive pressure ventilation is nothing but creation pressure that moves the volume of gas into the lungs. Most commonly, there will be two general method, volume control method as well as pressure control ventilation. You can proceed to next slide. First, volume control ventilation. Define volume control ventilation. Okay, volume control ventilation it is nothing but inflation volume, nothing but tidal volume. Tidal volume is nothing but volume of air inspired and expired during one breathing cycle. That is tidal volume or inflation volume, which is pre-selected, and ventilator automatically adjusts the inflation pressure to deliver the desired volume. Then proceed to the next slide. Then define pressure control ventilation. Okay. In volume control ventilation, inflation volume or tidal volume which is pre-selected. In pressure control ventilation, inflation pressure is pre-selected. And duration of inflation is constant in pressure volume control ventilation. Pressure control ventilation, duration of inflation is adjusted by the operator to deliver the desired volume. Mostly duration of inflation, which is high during earlier part of the pressure control ventilation. During later part, it is slowly decreases. Finally, it reaches during, and finally decreases to zero to deliver the desired tidal volume. Then the duration of inflation is not constant in pressure control ventilation, which is constant in volume control ventilation. Okay, we can proceed to next slide. It's a basic difference between the pressure control ventilation as well as volume control ventilation. This is the three parameter. First, on the left side, which shows volume control, on the right side, which shows pressure control. First will be the volume graph, second will be the pressure graph, third will be the flow rate graph. In volume control ventilation, inflation volume is pre-selected, which is constant, which is constantly increases. Then the center will be the duration of inflation, which is constant. Then it suddenly, after the inflation pressure is reached, it suddenly decreases to zero. Then the expiration phase will be takes place. In pressure control ventilation, the inflation pressure which is constant, so it is inflation volume which is suddenly increases during early part of the mechanical ventilation. Once it reaches the peak pressure, it suddenly drops to zero in flow rate for the flow rate curve in the pressure control. This is the basic difference between volume and pressure control. And second will be the airway pressure gap. Then in airway pressure gap, the volume control ventilation, duration of inflation which is constant. Then inflation, because inflation volume will be pre-selected, then airway pressure will be increases during inspiration and decreases during expiration. In airway pressure, there will be a in airway pressure in volume pressure control ventilation. There is inflation pressure is pre-selected because inflation pressure is constant. Inflation volume will be increases during early part of the ventilation and suddenly drops during expiration. Suddenly drops to zero. There will be a pressure peak inspiration pressure and plateau pressure in the volume control ventilation. That is only peak pressure, peak inspiratory pressure in the pressure control volume. There is no plateau pressure, or otherwise peak inspiratory pressure as well as plateau pressure both equal in pressure control ventilation. In volume control ventilation, there will be a peak inspiratory pressure as well as uh, plateau pressure. Plateau pressure not will be inspiratory hold during the end of the inspiration. Then there will be some pressure in the inspiration. In volume control, then there will be no pressure in the no airway pressure during the end of inspiration in the pressure control ventilation. This shows the flat graph in the airway pressure of the pressure control. Then there is a peak in the volume control ventilation. There will be the tidal volume. Similar to airway pressure, there will be a tidal volume. Is a gap showing ventilation starts with a peak inspiratory pressure because start from zero. Then ventilator, if you set the PEEP on the ventilator, it starts from not from the zero end inspiratory pressure, it starts from peak inspiratory pressure, peak end expiratory pressure, which is set up in the ventilator. Normally we set around 5 to 8 centimeter of water. So it's the inspiration, it starts from the peak end inspiratory pressure. Then it progresses to the peak inspiratory pressure. Then it falls to the peak plateau pressure. Plateau pressure, there is nothing but inspiration. There will be airway occlusion pressure at the end of inspiration. This is nothing but plateau pressure, which is only present in the volume control ventilation, not present in the pressure control ventilation. Because in pressure control ventilation, peak inspiratory pressure which is equal to the plateau pressure. During expiration, the upper part of the curve showing resistance flow and lower part of the graph showing compliance. And other end, there will be ortho-PEEP, particularly in condition where in a COPD or bronchial asthma, there will be ortho-PEEP due to dynamic air inspiration. In ortho-PEEP, there will be expiration is not complete. Before expiration is complete, another inspiration comes, which will cause ortho-PEEP. Then volume cycle ventilation. During volume cycle ventilation, pressure in the airway rises steadily until the pre-selected tidal volume, which is before similar to the volume control ventilation. During volume cycle ventilation, pressure increases and tidal volume remain constant. PAW nothing but airway pressure at the end of each lung inflation. Peak nothing but peak airway pressure is the pressure needed to overcome the both resistive and elastic forces in the lung and chest wall. Then peak pressure equal to pressure of resistance as well as plus pressure of elastin. Resistance pressure nothing but function of resistance to flow in the airways as well as inspiratory flow rate. Elastance pressure nothing but function of elastic recoil of lungs and chest wall and lung volume. This is accomplished by occluding the expiratory circuit at the end of lung inflation to prevent the patient from exhaling. And similar to the previous gap, starts from either PEEP or it starts from zero airway pressure. Then the inflation will be proceeded to the peak inspiratory pressure. Again, during inflation mode, it progress down to the peak plateau pressure, nothing but alveolar pressure. Then in center part of that, there will be inflation. Then again the deflation during expiration. Here there was showing resistance pressure and later bar showing elastic pressure. This is the figure shows airway pressure profile at the constant flow volume control and inflation. It a brief in inspiratory occlusion, that is nothing but inflation over, that is nothing but plateau pressure. P pressure is the peak airway pressure. P plateau is the air inspiratory occlusion pressure. P alveolar is nothing but peak alveolar pressure at P inspiration. Thus, P rest is nothing but pressure attributed to the airway resistance, and P EL is the pressure attributed to the elastic recoil force of the lung and chest wall. During the inflation hold maneuver, the pressure in the airways decreases initially and remains constant until the occlusion is released. And the patient is allowed to exhale. This is the inflation hold maneuver. Inflation hold maneuver are nothing but plateau pressure. And the plateau pressure is the peak pressure in the alveoli at the end of inspiration. This is called steady occlusion pressure. There will be two formulas. First for resistance pressure as well as elastic pressure. Resistance pressure nothing but peak pressure minus plateau pressure. Elastic pressure nothing but plateau pressure minus positive end expression pressure. This is in previous slide we shows that the inflation hold maneuver, then the pressure in the airways decreases initially and remains constant until the occlusion is released. Then the patient is allowed to exhale by blocking the expiratory circuit. This is the inflation hold maneuver. That is plateau pressure nothing but peak pressure in the alveoli at the end of inspiration. This is called steady occlusion pressure. We have elastic pressure as well as resistance pressure. Elastic pressure nothing but plateau pressure minus positive and expiratory pressure, and resistance pressure nothing but peak pressure minus plateau pressure. Then end expiratory pressure is the minimum pressure in the alveoli. Note that point, minimum pressure in the alveoli or airways during the ventilatory cycle. Airways mostly in the inspiratory pressure and alveoli in the end expiratory pressure. There is a different form of end expiratory pressure as follows. First one, zero end expiratory pressure. Zero means no airflow at the end of expiration, and the pressure in the alveoli is equal to the atmospheric pressure. That is nothing but zero end expiratory pressure. Then next will be the applied PEEP. Applied PEEP nothing but applied positive end expiratory pressure. This is for prevent the collapse of distal air spaces at the end of expiration, or also for opening the collapsed alveoli to improve the oxygen supply of the patient. It is nothing but applied PEEP. It having main advantages of opening the collapsed alveoli and as well as prevent the collapse of distal air spaces. And next will be the occult PEEP or intrinsic PEEP, nothing but auto PEEP. It is nothing but continuous airflow at the end of expiration. So lungs do not completely empty during expiration, then alveolar pressure remains positive even though the proximal airway pressure falls to the zero atmosphere. It is most commonly occur in the condition nothing but chronic obstructive pulmonary disease as well as bronchial asthma. Most commonly in anesthetic procedures, laparoscopic surgery, especially for the bronchial asthma patient, intrinsic PEEP will be occurs. And this is the graph showing zero end expiratory pressure as well as applied PEEP. Applied positive end expiratory. Note that zero end expiratory starts from airway pressure zero. Applied positive end expiratory pressure, it is above from the baseline. Then occult PEEP. Occult PEEP is nothing but intrinsic PEEP. In intrinsic, airways do not completely empty during expiration. Then the alveolar pressure remains positive even though the inspiratory pressure falls to zero. Nothing but end expiratory obstruction. This is the graph showing flattening showing and expiratory obstruction most commonly occur in chronic obstructive pulmonary disease as well as bronchial asthma. And mean airway pressure. Mean airway pressure is nothing but airway pressure in the average pressure in the airway during ventilatory cycle infused by several variable including peak pressure, contour of pressure waveform, positive and expiratory pressure level, respiratory rate, and inflation time relative to the total time of the ventilatory cycle. In mean airway pressure in normal lung around 5 to 10 centimeters of water. In airflow obstruction, the pressure increases to 10 to 20 centimeter further. In non-compliant or stiff lung, nothing but 20 to 30 centimeter further. The mean airway pressure is also is the important parameter in ventilation. Mean airway pressure is the average pressure in the airway during ventilator cycling, influenced by several variables. For mainly peak pressure, contour of pressure waveform, positive end expiratory pressure level, respiratory rate, and inflation time relative to the total time of the ventilatory cycle. And conventional mode of ventilation. We proceed to the conventional mode of ventilation. First, volume control. Previously explained like that. That is nothing but inflation, tidal volume, which is pre-selected, and lungs are inflated at constant flow rate until the desired volume is delivered. It having advantages as well as disadvantages. Main advantage is having constant tidal volume. And most commonly preferred in hemodynamically unstable patient. Patient comes with septic shock or any cardiogenic shock. Most commonly used mode will be the volume control ventilation, but it having disadvantage of high airway pressure. So it is most commonly avoided in patients with any lung pathology. Then these are the following modes available in the ventilator. First will be the volume control, either controlled ventilation, assist control ventilation, or control mandatory ventilation. Next will be the intermittent mandatory ventilation. Then another will be a pressure regulated volume control ventilation. Next will be the pressure support or continuous positive airway pressure. Then other parameters. First volume control, pressure control. Then pressure regulated volume control ventilation, pressure support or continuous positive airway pressure, volume support, then synchronized intermittent mandatory ventilation. It's a volume control plus pressure control. It is mainly volume control ventilation. Another parameter, another mode will be a synchronized intermittent mandatory ventilation with pressure support. Another will be a synchronized mandatory ventilation with pressure regulated volume control. Another will be the bilevel positive airway pressure or airway pressure reduced ventilation. This is the modes available in our ventilator. Then volume control ventilator with the following parameters to be adjusted. First will be the tidal volume. Normal tidal volume around 6 to 8 ml per kg. For adults, it is normally fixed around 500 ml. Respiratory rate. Next parameter will be the respiratory rate. Normal respiratory rate for males 14 to 18 and females 12 to 14. We set around 15 breaths per minute. And positive end expiratory pressure. Normally we set around 0 to 5 centimeter of water. Then FiO2, fraction of inspired oxygen concentration. Normally we want to set above the atmospheric pressure. Oxygen around more than 21%. We keep around, for example, we keep around 60%. Then inspiration and expiration ratio. Inspiratory ratio will be normally will be less than the expiration. We want to give more time for inspiration to prevent or to keep. So inspiration will be less than expiration will be lower. Most commonly used will be 1:2. And the inspiratory rate as well as keepers and trigger flow. After setting the parameter, we click to accept and proceeding to the ventilation. For example, we connect to the test lung by start ventilation. This is the video showing how to start ventilation. By clicking the start button, this is the test lung showing it moves by inspiration and expiration. By showing the back movement is occurring. Showing the back movement and following graphs, we can show the following parameter: tidal volume, respiratory rate, peak and inspiratory pressure, as well as oxygen concentration. Is the set value and the opposite is the patient deliver patient volume. Then the following first will be the volume, second will be the pressure. First will be the pressure gap, second will be the volume gap. First will be the volume gap, second will be the flow rate, third will be the volume gap. Then proceed to the pressure control ventilation. Desired inflation pressure is pre-selected and decelerating inspiratory flow rates provide the high flow at the onset of lung inflation to attain the desired inflation pressure quickly. The pressure control, inflation pressure is pre-selected. And the tidal volume and inspirated fluid, which is high during early onset and progressively to achieve the desired temperature, it is progressively falls to zero. Then it having following advantage and disadvantage of the having constant peak alveolar pressure to prevent alveolar distension as well as ventilator induced lung injury. Disadvantage of decrease in alveolar pressure when there is an increase in alveolar resistance or decrease in lung pressure, particularly in acute respiratory failure, as well as it having the this is the parameter for pressure control. First, pressure volume. We want to set the pressure volume, pressure control above positive end expression pressure. We said, for example, we set P per 5. We want to set pressure above 5. For example, we set around 20 centimeter per water and respiratory rate 14 to 18 for males and 12 to 14 for females. Then that parameter will be positive end expression with this normal value of 0 to 5 centimeter per water. Then FiO2 and the set about 21%. Then next will be the inspiration as well as expiration. Inspiration expiration ratio we keep around 1:2. Then the inspirated rate as well as ticket score. Once the parameter is set, we want to click the accept button, then proceed into the ventilation. Then recently to overcome the advantage of both pressure control and volume control ventilation, there is a newer mode that is nothing but pressure regulated volume control ventilation. This is nothing but hybrid mode of ventilation. We give like both volume control as well as pressure control because it having constant tidal volume like volume control and limit the end expiratory airway pressure like pressure control. It having both advantage of volume control and pressure control and to eliminate the disadvantage of both volume control and pressure control. Even though the more having several advantages, most commonly used more will be the volume control and pressure control. And next proceed to the assist control ventilation. In assist control ventilation, allow a patient to initiate the ventilated breath, but it is not possible when the ventilated breaths are delivered at the pre-selected rate. That is nothing but control or time trigger ventilation. This is divided into again volume control or pressure control. In controlled mandatory ventilation, ventilator breaths will be only delivered. In assist control ventilation, patient also able to initiate the ventilator breath. Is the following having several modes. First, we can see the patient triggered breath, followed by ventilator breaths in assist control ventilation, then time triggered breath initiated by the ventilator. Another one more will be a rapid patient triggered ACP. There is a continuous inspiration and expiration. There is a no time for expiration to complete. So it having disadvantages, centers having auto peep. Then another way more reverse synchronized intermittent mandatory ventilation. The bigger graph showing ventilator breath and the smaller graph showing spontaneous breath, which is delivered by initiated by the patient. Next, we will synchronize intermittent mandatory ventilation. Intermittent mandatory ventilation is designed to allow the spontaneous breathing between the ventilated breaths. It is similar to the assist control ventilation. Accomplished by placing the spontaneous breathing circuit in parallel with the ventilation circuit with unidirectional valve that opens spontaneous breathing circuit when the ventilator breaths not delivered. It is again similar to assist control ventilation. It is again divided to the volume control or pressure control ventilation. This is the image showing synchronized intermittent mandatory ventilation, which is the volume circuit. These are the parameters to be adjusted before connecting the ventilator to the patient. First will be tidal volume around 500, then synchronized intermittent mandatory rate around 15, peak around 0 to 5, FiO2 more than 21%, we want to keep. Then inspiratory expiratory ratio 1:2, then T pause, T inspiratory rise, breath cycle, trigger flow as well as inspiratory cycle. And for pressure support above if we want to do, for example, in this image, we want to keep above 5. We set in image as 18. Then all necessary parameters are adjusted, click to accept, then proceed to ventilation. Similar to SAME volume control is a pressure control. Instead of tidal volume, we can see the pressure control above P. So more than 5 we want to set in this image. we set around 20. Then others similar to the volume control, SA rate, positive and expiratory pressure, FiO2, inspiratory expiratory ratio, T inspiratory rise, breath cycle, trigger flow, inspiratory cycle of PS above P. Then click to accept button and proceed to ventilation. And pressure support ventilation. It is to overcome the disadvantages of pressure control ventilation. Then pressure augmenter is nothing but pressure augmented spontaneous breathing. It is differs from patient trigger pressure control ventilation because patient allowed to terminate the lung inflation in pressure control ventilation in pressure support ventilation, where ventilator terminate the inflation with pressure control ventilation. It having patient and adjust the tidal volume as well as duration of lung inflation in pressure support ventilation. This is the image showing during flow rate. First image that is more inspiration phase, the tidal volume is increased. After inspiration, tidal volume is held with this later inspiratory flow private at 25% of peak flow, it is suddenly drops to 0. So in this image, the change in pressure and flow during single lung inflation with pressure support inflation. Lung inflation is terminated when the inspiratory flow rate falls to 25% of peak flow rate, which allow the patient to determine the inspiratory time as per tidal volume. Next, we proceed to the ventilatory settings. It having controlled mechanical ventilation, controlled mandatory ventilation, as well as synchronized mandatory. Patients having initiated spontaneous breath prefer synchronized intermittent mandatory mode of ventilation. If the patient is completely upping, that is no spontaneous breathing, but then prefer controlled mechanical ventilation or controlled mandatory ventilation. Then next will be the pressure control versus volume control ventilation. Patient is hemodynamically unstable, mostly prefer volume control ventilation. Patient is hemodynamically stable, prefer pressure control ventilation. Pressure control ventilation is usually preferred during weaning from ventilation to avoid the increased tidal volume to avoid barotrauma. Tidal volume. First, we want to take the tidal volume around 8 ml per kg by using predicted body weight. Predicted body weight nothing but formats 50 plus 2.3 into 18 inches minus 60 for females to 45.5 plus 2.3 into 18 inches minus 60. And next will be a reduced tidal volume to 6 ml kg over next 2 hours if possible. And monitor peak alveolar pressure and keep it tested 30 centimeters of water. And next will be the inspiration and expiration ratio. Inspiration and expiration normally more than 1:2. Following condition, inspiratory expiration ratio will be less than 1.1:2. And option for increasing the inspiratory ratio include increasing the inspiratory flow rate, decreasing the tidal volume, or decreasing the respiratory rate, most commonly to prevent autowave during in patients with bronchial asthma or chronic obstructive pulmonary disease. We want to keep expiration time to be more. So ratio should be 1 is less than 1:3. It is suggested to 1:3 or 1:4, like that. Respiratory rate. The patient has no spontaneous respiration, set the respiratory rate to achieve the estimate of patient mechanical ventilation just prior to intubation, but not exceed 35 breaths per minute. Patient is triggering each ventilator breath at the machine rate. Below the patient is spontaneous respiratory rate, like in synchronous intermittent mandatory ventilation mode. After 30 minutes, check arterial PCO2 in ABG or adjust respiratory rate to achieve desired CO2. Next will be the positive and expiratory pressure. Set the initial PEEP to 5 centimeters of water to prevent the collapse of distal air pressure at the end expiration to increases the oxygen supply of the patient. Further increase in PEEP required in following condition. A toxic level of oxygen is required. For example, more than 60% is required to maintain the saturation more than 90% for adequate oxygenation. Or hypoxemia respected to the oxygen therapy conditions like ARDS, acute respiratory distress syndrome. Then the alternate mode of ventilation. Alternate mode of ventilation are available. This conventional mechanical ventilation is not necessary in patient with acute respiratory pressure. This is otherwise known as non-invasive mode of ventilation. This is normal continuum positive airway pressure, level positive airway pressure as well as pressure support ventilation, similar to in used in synchronous intermittent mandatory ventilation or oscilloscopic ventilation. Your ventilatory modes, nothing but airway pressure, release ventilation. Airway pressure, release ventilation, like prolonged period of spontaneous breathing and high end expiratory pressure, which is interrupted by brief periods of pressure relief to the atmospheric pressure. So variant of CPR, which is spontaneous breathing under positive end expiratory pressure. Then CPR volume is around 0 to 5 centimeter of water, but airway pressure mostly maintained at high end expiratory pressure, like 30 centimeters of water, it suddenly drops to atmospheric pressure to 0 or 10 centimeter of water. From 30 it drops to 10 but mostly maintained at end expiratory pressure of there around, for example, 30 centimeter of water. The image showing continuous positive airway pressure release ventilation as well as bilateral positive pressure. For continuous positive airway pressure, it is pressure is maintained around 5 centimeter of water during both inspiration as well as expiration. For airway pressure release ventilation, mostly pressure is maintained at high end expiratory pressure like 30 centimeter of water. It is for small period, it suddenly drops to 0 or atmospheric pressure. Then bi-level positive airway pressure, it is similar to the airway pressure ventilation. In airway pressure ventilation, it is mostly higher times spent in high end inspiratory pressure. In bi-level positive pressure, higher more time spent in lower expiratory pressure, like 5 centimeter of water. Only small period of time spent in around high pressure, like 10 centimeter of water. Higher pressure, nothing but inspiratory positive airway pressure. Lower pressure, nothing but in expiratory positive airway pressure. And non-invasive ventilation. Non-invasive ventilation is intended for patients with acute respiratory failure who benefits from ventilator support but not need conventional mechanical ventilation. Non-invasive ventilation is delivered with tight fitting mask, which obviates the need of endotracheal ventilation. It is nothing but non-invasive ventilation. Continuous positive airway pressure is nothing but continuous positive airway pressure is spontaneous breathing and deep or positive end expiratory pressure. Require only a source of oxygen and face mask with the end expiratory valve that maintains deep. Principal effect to increase the FRC or functional respiratory capacity. Functional respiratory capacity nothing but volume of air exhaled after normal expiration. Continuous positive airway pressure is set around 5 to 10 centimeter of water. Limitation CPR is a limited form of ventilative pressure. It does not augment tidal volume and limit the use in acute respiratory failure. The image shows pressure support or continuous positive airway pressure. In this, we can adjust the pressure support above PEEP, nothing but more than above PEEP. For example, above 5 centimeter of water. We set around 20 centimeter of water. Next will be the parallel PEEP. Then next will be a FA water. Next will be the inspiratorized. Next will be a trigger flow. Next will be inspiratory setting. Then it accept before connecting to the pressure. Before. Next modular bi-level positive airway pressure. It is nothing but continuous positive airway pressure that alternate between two pressure. It is nothing but volume of airway pressure release ventilation. Only difference between them is the amount of time allotted for higher low pressure level. Airway pressure release ventilation most of the time spent at higher pressure level, while by level positive airway pressure most of the time spent at low pressure level. High pressure level in bypass nothing but inspiratory positive airway pressure. Low pressure level in bypass nothing but expiratory pressure, expiratory positive airway pressure. Ventilator settings. Nothing but inspiratory positive airway pressure is, for example, inspiratory positive airway pressure mostly sets around 10 centimeter of water. Expiratory positive airway pressure sets around 5 centimeter of water. Inspiratory time around 3 seconds. Peak pressure nothing but inspiratory positive airway pressure plus expiratory positive airway pressure nothing but add both leading to the 10 plus 5 at around 15 centimeter of water. Adjust the pressure because of gas exit. PaO2 by FiO2 ratio or PaCO2 are signs of respiratory distress. Peak pressure about 20 centimeter water is usually not always because the poorly tolerated by patient also promote leaks. Pressure support ventilation similarly used in asset control ventilation provides pressure trigger inspiration and pressure augmented tidal volume. Inspiratory flow rate. Before that, we can see the image. There is the inspiratory flow rate. We have decelerative flow pattern and pressure augmented tidal volume is terminated and inspiratory flow rate decreases to the 25% of peak level. CPR is usually combined with PSB to increase the pressure. The image, I can show the image. This image on it. Inspiratory flow rate, inspiration suddenly increases and falls during inspiration. There will be a deceleratory inspirated flow rate. Once it achieves the 25% of peak flow, it falls to zero. Then, who are the patients required for non-invasive ventilation? By clicking the following parameters. Does the patient have signs of respiratory distress and having PaO to FiO2 ratio is less than 200 and PCO2 more than 45? If both answer is yes, then proceed to the following. Patients: respiratory failure, imminent threat to life, all life-threatening circulatory disorder, coma, agitation, uncontrolled seizure, inability to protect airways, hematemesis or recurrent facial trauma, or recent head surgery. If it is more to all the patient, patient is candidate for non-invasive ventilation. All the parameters is yes, then proceed to a invasive ventilation. Then we can click non-invasive ventilation by in standby mode. We can select instead of invasive ventilation, we select the non-invasive ventilation, and also we can select either adult patient or infant patient. In NIV, non-invasive ventilation, we are having two modes: pressure control as well as pressure support. We can change it from adult to infant by clicking the infant button. This is the graph showing volume control ventilation. First will be the pressure graph, second will be the flow rate graph, third will be the volume graph. These are the following parameter: oxygen concentration, speed, respiratory rate, tidal volume. And this is the patient delivery report, patient delivered parameters in the right side of the column, right side of the monitor. We can check the alarm whenever there is the airway pressure is low. By the alarm zone it will alert the intensivists or anesthetists or any other CMOs available in the intensive care setting. It having showing oxygen concentration is high, peak pressure is high, and as well as mean ventilation is less than 5. Is the image, the video showing SIMA pressure control ventilation having oxygen concentration of 100%, which is toxic to the patient, causes oxygen toxicity. Red color alarm will be indicated. This is the oxygen concentration high, which is 100% oxygen, it is toxic to the patient. Then next alarm will be the low expiratory minute volume, which is less than 5 liters per minute, and also oxygen concentration is high. It may be any leak in the circuit. We can detect by we can check in the patient, and also image showing low minute volume, which is less than 5, showing red color indication. And we can, because there is a low tidal volume, we can increase the tidal volume. It increases to. So when you increase the tidal volume, the minute volume will be slowly increasing. Yes, from 1.9 it proceeds to 3.2, 3.8, 4.5, then 5.2. Then alarm goes on, only 100% oxygen alarm will be showing. You can see the acute access by seeing the loops, low volume loops as well as volume pressure loops. We can set the alarm profile by setting the upper and lower volume. For example, pressure will be lower pressure will be 0, higher pressure will be 40, and the volume lower will be 2 liters per minute, higher will be 5 liters per minute. Respiratory rate will be low, normal will be 20 and more will be 50, and the expected also lower will be 10 and higher will be lower will be 2, higher will be 2. Sound level will be 100%. By maximum button, we can know the alarm setting. And we can see the trends by clicking trends button. We can see the trends of P peak, peak plateau, P mean, peak as well as expired inspirated as well as expired time volume as well as spontaneous inspirated as well as respirated. Is the picture showing me heat moisture exchanger which is connected between the test lung as well as end of piece which is connected to the airport. Thank you. Thank you for the patient listening.